And there is the classroom code. If you haven't done it yet, write it down. And when you get your Chromebook out a little bit later, because I don't have a handout for you today, you can make sure you sign in to the classroom so that you get that so you can keep up to date there. Okay, so don't write all this down, but we're just going to talk about it. So you can put your pencil down for now and just relax for a minute. You learned about this in elementary school, about equations. And I bet you at some point, or in grade 9 as well, I bet you at some point your teacher talked about how an equation is like a scale, like it's balanced, right? It's got the same amount of weight or something on both sides. So I'll give you an example. Imagine I have 10 pounds, one 10-pound weight on this side, and 5 2-pound weights on that side. It's balanced, right? 10 pounds on each side. Okay? What happens if I add 3 pounds to this side? I have to add 3 to this side to keep it balanced. What happens if I double the weight on this side? So I got 20 pounds now. I have to double the weight on this side to keep it balanced. What happens if I take away 3 pounds from this side? I got to take away 3 pounds from this side, right? And that's exactly what happens. Like, you can think about that while you're solving equations. You can think about how whatever I do to one side, I have to do to the other side. People come up with all these little tricks, and as long as it works for you consistently and you understand it, you understand why, it's probably fine if you're getting the right answers. But be careful making up your own tricks. Sometimes they only work in some situations and they don't in others. But what solving equations always is doing the same thing to both sides to keep it balanced. So keep that in mind always. And as we're working today and tomorrow on this stuff, we're going to do a couple of days of solving equations, and that will help you keep you on the right track. What does it mean to solve an equation? When I look down here, for example 1, it says solve each equation. But what does that mean to solve an equation? So the example that I gave is not very interesting. The example I gave is 10 pounds equals 5 2-pound weights. There's nothing to do there, though, right? It's true, it's balanced. 10 equals 10. Big deal, right? But when I have an x involved, so if I look at this one, there's an x. So something equals -4. But I don't know what the something is. So that's what we're trying to do. This is a huge part of mathematics. And when we solve these equations, it might seem easy, and it might seem like, why do I need to know how to do this, right? People always ask that question. Like, I don't see how this is useful, but trust me, this is like mathematics. A huge part of it is setting up equations that are more complicated than this, but then finding out the x that we're looking for, figuring out those unknowns, right? That is a big part of mathematics, even like higher end mathematics that people do. So that's what we're trying to do. We're trying to solve the equation, which means find the x. Find the value of the variable that makes the equation true. I could put in any variable. What if I put 10 in here? If I put a 10 in, I get 16. That does not equal -4, so that's wrong. What if I put 5 in here? 5 plus 6 is 11, not -4, so that's wrong. So see how there's a whole bunch of x's that are not correct. We want to know the one that is. And some of you probably know what it is. Like, you guys think you know what it is? What do you think it is? -10. That's great. When it's an easy one like this, you can just look at it and know what the answer is. But when it gets harder, you can't. So if these are easy, you're like, I already know the answer. Why am I doing this? Well, because we're trying to build habits and skills that will help for the hard questions. So it will be easy today. You will get the right answer. You will often know the right answer. That's awesome. That's good. That means you know that you're right. But how do we show our work? How do we do the steps so that we're ready when it starts to get harder? That's what we're really working on. And again, that's what you'll get feedback on when you do your learning goal on this stuff. Did you show your work properly? Did you do the steps? Are you ready to move on to get to the harder questions? Okay. So sometimes we call this isolating the variable, getting the variable all by itself on one side, often the left side, but it doesn't have to be. Okay. So we want it to look like this, x equals. I don't want it to look like 2x equals. That's wrong. I don't want it to be -x equals. That's not done yet. Okay. I don't want it to be x over 15 equals. That's not done yet either. It has to say x equals. And believe it or not, we're not going to do this quite yet. It won't even seem like it, but this still does follow the rules of BEDMAS. Remember I made a big deal yesterday. When do we use BEDMAS? Always. Always, always, always. This kind of, we do it like in reverse BEDMAS, sort of. So you don't have to think about that. Don't think about BEDMAS backwards. You will probably know what to do naturally in most cases. But we are still following the rules of BEDMAS. Okay, so here's what we want to do. Let's get started. You can write this down, example 1. So this is what you do want to have written down in your notebook. Example 1, solve the equation A, write down the question, and let's get started. And here's how, whether it's a hard question or an easy question, a hard equation or an easy equation, this is what you can ask yourself. I'm trying to get x all by itself. Why is it not all by itself? Who's bothering the x that we need to get rid of? Not -4. Michael, the 6. The 6 is in the way. So I got to cancel out the 6. So how do I get rid of 6? What can I add or subtract or multiply or do to both sides? I have to do to both sides, but I'm just worried about getting rid of that 6. I subtract 6. Very good. How many people were thinking that you subtract 6? So here's how I'm going to show it. I'm going to subtract 6, but if I take 6 away from one side, what do I have to do? Take 6 away from the other side. Okay, and eyes up, just watch for a minute. This is what I like to do. Now, if you're good at this, again, you might be sitting there thinking like, oh my gosh, this is too easy. Like, Mr. Blair, come on, we're not stupid. Like, I get that. Okay? But when it gets harder, all of a sudden you need skills to figure out what to do. So here's a trick that I use. Some people are going to love this and some people might not, and that's fine. But when you get stuck, this might help. I ask myself, is this 0? Like, does that actually go away? Yeah, it does. In this case, it does. 6 minus 6 is 0. It's gone. So I end up with x equals, and you don't have to write this step. I'm just going to write it for now. That's what you end up with. And what is -4 minus 6? -10, just like you said. Right? Very good. Okay, next question. What's in the way of the x? What do we need to get rid of? Kareem? The 7. How do I get rid of a -7? Add 7. Very good. And if I add 7 pounds to one side, what do I have to do? Add 7 pounds to the other side. Is this 0? Yep. So I get 2, whoops, sorry, I'm just going to make it black here. 2 plus 7 equals x, right? 9. Awesome. 9 minus 7 is 2. Yeah, that works. So that is the right answer. You can see it in the question. But that's how we show our work. That's how we do our steps. Again, these are the really easy ones. These are the one step. We're only doing 4 of these. And you get to practice it a couple times on your own, but that's it. Okay. Next one. How do I get rid of, what is happening here? You're dividing. And what's the opposite of dividing? Multiplying. And the opposite of dividing by 4 is multiplying by 4. That's what's going to get rid of the 4. Okay? So I'm going to show it like this. So I'm just going to multiply by 4 on both sides. And again, I can ask myself, what's 4 divided by 4? It's 1, so that's good. That's what I wanted to happen. I just get 1x, or x. And I get 2 times 4, which is 8. Well, yeah, sure. So I looked at how this is x divided by 4, and I need to do the opposite to get rid of the 4. So I multiply both sides by 4. And 4 divided by 4 is 1, so that's gone. So 1x equals 2 times 4, which is 8. You can show that step if you want, so you can get x equals 2 times 4. And sometimes it's nice to show a little bit of extra work in the beginning, but then once it clicks and you don't need that step anymore, then you skip it. That's fine. The learning goal. If you're not sure if you're allowed to skip steps, I'll tell you when you hand in your learning goal, I'll say there's missing steps here. For full marks, you got to show them. So then you know. Okay? Okay, last one. This is the last type. We did adding, we did subtracting, we did dividing. What's this one? Ethan, what do you think? If I add 2, what's the operation there? Can you tell me what the operation is, Ethan? Not sure? That's fine. We did something similar to this yesterday, but we haven't quite done it yet. It's multiplication. How do you know that?
With the variable being right beside it, shows that.
Yeah. So when they're right beside, I'm glad this came up. When they're right beside each other and there's no, like if it was plus x, then you're adding. But since there's nothing written there, I'm multiplying. So what's the opposite of multiplying? Dividing. So I'm going to divide by negative 2. And on the other side, same thing, divide by negative 2. And you can ask yourself, negative 2 divided by negative 2, that's 1. So that works. You can even do it on your calculator if you want. Negative 10 divided by negative 2 is 5. Any questions? These are the easy ones. Okay, I want you to try a couple of those. I'm only going to give you about 5 minutes. Try a few of those. This is in the classroom. So if you want to pull up your Chromebook and log in there and look at it there, you can, but I'm going to leave it up as well. But then I'm just going to give you a few minutes to try a few of these on your own. Then we're going to go back to the lesson and do a few more that are a little bit harder. Not much, but just a little bit. Okay, finish up the one you're working on. Let's take a look at some slightly trickier ones. Okay, so that's fine, take another minute if you need to finish, and then back to the lesson, you can copy down this example. I'll zoom in a bit. So all those other like one-step equations, they were pretty easy, and like I said before, you might be able to get the answer just by looking at it. Something divided by 5 gives you 10. Well, right? Like it's easy. But already it gets a lot harder. You might be able to figure this out just in your head, because they're still not that hard, right? And they still make sense. But they start to get trickier quickly. And this is why even working on those easy ones, but doing it with the right form, really helps our thinking, because it makes us think, okay, what am I doing to this side? What do I need to get rid of? What do I need to move? What's the operation? Do the same thing to both sides. Like it gets you in the right mindset that you're doing all that stuff the right way. And then when you get to the harder ones, and even these might not be that hard. You might kind of blow through these, but trust me, eventually it will get trickier. And that's when you need to have the skills of how to break a bigger problem into smaller problems that you can do step by step. That's a big part of mathematics. Sometimes people think they can't do it. They can. They're just overwhelmed because they don't know where to start or that kind of thing. But you can do all the little steps. You just have to know where to start, what order to do them, how to break it up that way, right? So again, that's why sometimes we start with the easy ones. So for this one, 2x plus 3 equals 15. Remember I said you are doing these that have more than one operation. So 2x means 2 times x, so there's some multiplying. And then plus 3, so there's some adding. I got to get rid of the 3 and the 2. Which one do I do first? Reverse BEDMAS. So we're going to deal with the adding first. Okay, but I think most people, that's kind of like a gut feeling. You know that that's what you would do first. So how do I get rid of an adding 3, a plus 3? And whatever I do to one side, I want to do the same thing to the other side. And so then I ask myself, does that give me 0? Yep, so that's gone. And I end up with 2x equals, and you can write 15 minus 3 if you want, but you can also just write 12. 15 minus 3 is 12, so you can do that. And then what's my next step? I'm multiplying by 2, so Ryan? And divide by? Yeah, like the good rule is divide by whatever's in front of the x. If it's a -2, divide by -2. If it's a 10, divide by 10. If it's 0.6, divide by 0.6. And do it on both sides. You're trying to get, so it's just x. And there's nothing else with the x. So when it says x equals, you solved it. You figured out what x is, and you're done. X is 6. Some people don't write this down. Some people want to do it like this. They want to go 15 minus 3 equals 12. Whoops. Oh boy. Equals 12. And then they want to do 12 divided by 2 equals 6. So there's my answer, 6. That is not how you solve equations. When the equations get too hard, this won't work. And it doesn't show you're thinking the same way. It's not the way that we do it. So you really need to get on track with showing your work the same way that we're doing it here, okay? Okay, next one. This one can be a little bit tricky because it looks like subtraction. And the opposite of subtracting is adding. So what if I added 6? Ignore the rest of this. What is 6 plus 6? 12. Did that help us in any way? It did not. But what did I do wrong? If I want to ignore the rest of it, I'm just looking at the 6. I need to subtract 6 so that that's gone at 0, it goes away. Does that make sense? So that's gone. I'm left with negative 5y. Whoops, I forgot to do it on the other side. Show it on both sides, right? 31 minus 6, 25. These are just some of the examples. And then you do the same thing, right? I'm going to show you one more, then I'm going to let you try to do a couple on your own. These are just some of the hang-ups that people might find. This one was 2x plus 3. But in this case, those two parts are flipped. 6 minus 5y. That's enough that some people get stuck on that. And they add 6 because they do the opposite of subtracting. But you can see why that doesn't make sense. We're just thinking about the 6. 6 minus 6, that's 0. That's what we want. Yeah, very good. And can you tell me what you multiply by? The trick is whatever's on the bottom. So what's on the bottom? A y. So this is a bit weird, but this is why this question requires more than one step. You're going to multiply both sides by y. And again, this trick will always work. There are other ways that you can sometimes solve these kinds of questions. We don't see a lot of questions with y's on the bottom, but we see it once in a while. But this trick will always work. Multiply by whatever is on the bottom. That's going to make my life easier. Because y divided by y is gone. And I'm left with 20 equals negative 5y. And now this looks like something that I know how to solve. Go ahead and solve. You can finish that one on your own. Don't forget you're dividing by negative 5. 20 divided by negative 5 is negative 4. I can imagine some people might get 4, positive 4 by accident there. Should be negative 4. Any questions? Any questions? Any questions? Okay, I want you to try D. Even if you just want to think about the first step, try the first step. See if you can do it. Okay, so what did you do first? Who can tell me? Alexis, what do you think? Move the B to the other side. We could do that. That's a good way to do it. We're gonna do some of that stuff tomorrow, so I'm gonna see, does anybody do anything different? Did everybody move the B to one side? Brian, what did you do? Got rid of the 1. Either way will work. Tomorrow we'll see more about moving B's around. Alexis, you can tell me if you got the same answer afterwards. So I subtract 1, take 1 pound away from both sides, keep it balanced. 1 minus 1, that gets rid of that. 16 minus 1 is 15 equals negative B. And what's my next step? Miguel, what do you think? Not sure? Yeah, I could. That'll complicate things a little bit though. So something better to do, Ryan?
Cancel the B's to get a positive.
What about the b do I want to just get rid of, though? Just the negative. So how can I do that? I can divide both sides by -1, which actually just flips the sign. So you don't even have to show that. You can just say 15 equals -b. B is -15. You can just flip it over. You can only do that when it's like the last step. You can't do it if there's other junk in the way. But. Okay, what about the next one? See if you can figure out what to do first in the next one. What'd you do first for the next one? Ashley, what did you do? How'd you do that? But what did you do to cancel it out? Okay, good. So if I subtract it here to cancel it, it becomes a -1 on the other side. That's what you mean, right? Very, very good. Okay. How many people did that? Nobody? What do you mean? Okay, so you get x over 5, whatever's left. -9 minus 1 is -10. And now what do I do? Multiply by what? Why 1? It's a 5. On the bottom, you mean? Yeah, whatever's on the bottom, right? Multiply by whatever's on the bottom. Very good. Those are gone. X equals -50. I'm going to do this one quickly because I just want to show you something that can happen. So what would I do first? Subtract 10 from both sides. Okay, 10 minus 10 is 0. So again, that's gone. I get -4t. 57 minus 10 is 47. What do I do next? Divide by -4. Get your calculator out. No. What do you mean? No, I'm just going to show you something that can happen. Not a mistake. So if you get your calculator out and do 47 divided by 4, you get a decimal. And some people go, oh, I must have made a mistake because I got a decimal. It didn't work out. No, I mean, decimals are numbers. They're not different. Just like fractions are numbers. They're not different. They look different, but they're not. So -4 divided by 4, t equals -11.75. So sometimes you might get a decimal. I don't know that very many of the ones in the work today work out that way, but it happens. Check your work. There's nothing wrong with a decimal answer. Okay? Any questions? Questions. Okay, so you can